So this is problem number 3, ChemWiki, extra credit problem. And it reads, consider a pair of isomeric cationic complexes having a molecular formula of cobalt bis ethylamine diamine bromide perchlorate. One is optically active, but the other is not. So we need to write structural formulas showing each isomeric complex, but only one of the ions. B, what is the oxidation state of cobalt in these complexes, and how many d electrons are found in each one? So what A is telling us to do is to draw this complex. So cationic means that the complex, this one right here, has a positive charge. And we should already know that given the formula because this has a negative charge. Isomeric means that that has the same number of ligands, but they are arranged in different orders, which is what makes one of them optically active and one non-optically active. So let's draw this complex. So C, and bromide. So this is negative and this is positive. Okay, so let's draw the not optically active. Optically active. So what this means is that it has a plane of symmetry. Okay. And because En is a bidente, means it bites twice. So if it bites twice, it has 2 plus 2 more is 4 plus 2 is 6. So this is an octahedral. So there's the CO. Let me make that bigger. And a good way to make sure it has a plane of symmetry is to line up molecules that are the same on a plane. Here's the plane. So these are 2 are going back and these 2 are going front. This is the bottom of this is the top. So let's draw the ions because it bites twice. It's easier to put them on the plane itself. 2 bromides. So this has a plane of symmetry, and we have to make sure it's a plane of symmetry, which is right here. So you would cut the cobalt in half, cutting the ions in half as well. So one of the bromides would be on top and one of the bromides would be on the bottom. Okay, now the optically active. Again, same amount of ligands, same exact thing. So CO is going to be in the middle, of course. And the back, front, and the front. So a good way to draw an optically active one is to make sure it does not have a plane of symmetry. So you can purposely make this not have a plane of symmetry. So you can add the En right here. So one of the front ligands and the bottom ligand. And then the other En over here. So on the front and on the back, and the bromide's right here. So no matter how you try to put a plane of symmetry in the compound, in the complex, you cannot find it. You cannot cut this so that it has a plane of symmetry. So this makes it optically active. So plus ClO4, and let's make sure we write that on here. That's still part of the complex. Okay, that's for part A. And for part B, we want the oxidation state of cobalt. So, because it's an isomeric cationic, we know that the overall charge of this complex right here is positive. So it means it has one less electron, because the other electron comes from the perchlorate. So these two are they have the same amount of ligands, meaning it's going to have the same oxidation state for cobalt on both. So part B. It's CO, En2, Br2, positive, Cl, negative. And En has no charge, so this has a 0 charge. This has a 0 charge. Bromide has a -1 charge, and we're looking for this. And the overall charge is positive. So it's going to be positive 1 over here. This is -1, and there's 2, so that's -2 plus 0 plus X for cobalt. So X is equal to, let's move this over here, +3. So cobalt is equal to +3. That is its oxidation state. And we also want the D electrons. So we're going to do this using a short way. So cobalt is right here, element 27. And we're going to use the shortcut. So we're going to take, AR, element AR. And then we have its row number 4. These are the S. So 4s2. And then here are the d orbitals. It has 1, 2, 3, 4, 5, 6, 7. And it is row 3. So 3d7. And because it has a +3 charge, we have to take away 3 electrons. So we're going to take 2 from here, these 2, and then 1 from the 7. So it's 6.